Okay, great. We are live. So, hi, welcome. Thank you for joining. Appreciate our committee members for being here. This is part 2 of Navigating Ethereum. So we came up with this fun idea that we were going to explain how Ethereum works using transportation analogies, and many of them are super helpful in clarifying and giving kind of an overview. Some of them less so, which we will then use to explain how it actually works within Ethereum, because it's not a perfect analogy. But if you missed the last stream, no need to watch it right now. You can watch it after and still catch up. We're not making the assumption that you understand everything from that stream, so you should be able to follow along. I'm Jessica Levesque. I am C4's Executive Director, and we've got our Certified Ethereum Professional Committee with us today. And before intros, I want to reiterate, and I know we've talked about this on past streams, but our committee are the people who come up with our CEP exam questions and the content that should be on it. So they're all experts in different ways within the ecosystem, and then they come together to create the content that, as a community, we think others in the community would benefit from understanding and improving their knowledge of. So in the interest of education, that is our stream on explaining Ethereum. So let's do intros. Who wants to start? Kent?
Hey guys, Ken Barton here. I am a longtime C4 member. Also relevant to today's discussion, I used to be the head of the Tokenomics workstream at Shapeshift DAO. Also kind of relevant to what Jess was just talking about with C4. The two of us had the pleasure of collaborating on the C4 CEP study guide. So as we dig into this stuff, if concepts are feeling a little bit like far out, like, well, you need to really dig in and learn more, we have a study guide just for you. And it's really, we wrote it in a very sort of evergreen way that even though a lot of this stuff changes over time, this is quite evergreen. So remember, that's always a resource as well.
Yeah, thank you. There's the prep book and a study guide, both things that will help you along the way to make sure that you can become a CEP. So, all right, Josh.
Hey, Josh McDougall, one of the founding members of the C4 organization, and certainly a proud member of the Certified Ethereum Professional Committee as well since its inception. And I get to make blockchain video games in my day-to-day life.
I love that. I get to.
I get to. It is fun. Dustin?
Hi, my name is Dustin. I'm based in Singapore, and I work on a community in Singapore, Block 6, E65, which is a non-profit community for the local Ethereum ecosystem here.
Awesome. And we also have Sonal Patel on the call. She is one of the co-founders of Interweave, which is a consensus mesh spinoff, and is working with zero-knowledge proofs in order to improve how telecom communications work behind the scenes. And she will be on in a moment. She's just finishing up another call, but we will get started, and then Sonal will be on camera when she is able to. Excuse me. Okay, so last time on Navigating Ethereum, we talked about how there is an infrastructure inversion happening where we have built this incredible technology, but not everything has caught up that is needed in order for it to scale and be utilized in the way that it can and will be. And we talked about how with this technology that's advancing, there are a lot of little pieces to it that are helpful to know, which is things like the difference between Ethereum blockchain and the EVM, proof of work or proof of stake, gas fees, price limits, wallet keys, addresses. All of that was covered in the first stream. And we, per usual, were like, we'll be able to cover all of this in one stream, and then haha, no way. So we're on part 2 of that, and we're going to be talking first about asset types. So we know that within Ethereum and the cryptocurrency ecosystem, there are a lot of different assets, and you might hear someone use the word ETH or Ether to talk about Ethereum's native cryptocurrency. And let's get into the other types of assets. So why don't we the most common term that we hear, I think, is just a token. So Kent, do you want to get us started with what a token is? And then we're all just going to jump in on this to explain the differences.
Yeah, so let's kind of dive back into our fun futuristic Ethereum city. You know, there's a lot of potential analogies we could have applied to this, and
Sorry,
you'll see
Kent, I
that.
don't mean to, oh, never mind, you got it, Dustin. Never mind. Okay, start again. There was something on the screen I didn't know if Dustin knew was showing. Go ahead.
Okay, cool. Yeah, we settled kind of on this like city analogy and transportation analogy because it's fitting in a lot of ways. You know, you can always apply your own favorite analogies to this, but let's kind of return to this fun, futuristic, thriving city and think deeper about it. The token stuff gets really powerful, and I think is one of the core reasons why blockchain technology has been successful and has remained, things like Ethereum have remained decentralized. And we'll dig into that in a little bit in terms of tokenomics. But uh, in the context of our metaphor, a good way to think about a token is simply like a bus ticket. This is a way to access a specific service, you know, a bus, a train, what have you, or you know, a really cool sightseeing thing, a tourist attraction, something you want to use or do. Um, in the case of this, of course, you're accessing with Ethereum, ETH, the native token, gives you the ability to use the blockchain to do all sorts of things. You can use a decentralized application, you can publish and operate a decentralized application, and do all sorts of things under that umbrella. So you know they're usually issued for a purpose. It could be like a utility or a way to interact with a specific system like adapt. But there's other little nuances too. And it again, that's where it gets kind of to me, it gets really exciting and interesting because every token is kind of different. It's a unique, but yeah, at a very high level, that's essentially what a token is.
Awesome. Anyone else want to add into tokens before we move on to another type of asset? Great. Perfect, Kent. You're 100% for the day. Hey, Sonal. So,
Hello.
okay, we've got a token like a bus ticket, like Kent just said, and they have a purpose, they have utility. So actually, Dustin, if you want to stay on the first one, let's also, although these images, they don't explicitly explain, so I guess actually it doesn't really matter. But what we want to talk about next is what a coin is versus a token. So who wants to jump in to talk about how a token is different than a coin? Or coin is different than a token?
I mean, a coin is just seen as a little bit more general purpose, just like the coins in your pocket are you know available for spending as you go about your day. Where a token, you know, going back to what Ken was saying, generally has a specific, not necessarily single purpose, but maybe a collection of finite purposes for that one token, what it's supposed to accomplish. Whereas a coin tends to be a little bit more, you know, general, has many different uses in an ecosystem, and you know there is certainly gray area. Obviously, Ethereum or Ether, as Kent was saying, has a purpose in that it's actually to fund your interactions with the Ethereum blockchain. At the same time, it can also be used kind of as a transfer of value or as you know, other kind of financial purposes within the Ethereum network. So although you know we're defining these when it comes to asset types, there's a lot of overlap. There's a lot of ways to kind of turn and see how these different things kind of relate. But a coin, again, a little bit more general purpose, a general way of saying a cryptocurrency, which kind of gets to our next thing. There's a lot of slang used in these. Similar, you know, you can call a taxi or you can call a cab. Well, we can call these things coins just because kind of easy. It's what we know in our normal day-to-day. Token gets a little awkward, or helps you be a little bit more specific with it, depending on kind of how you see fit.
Yeah,
Now,
Can I
Sorry,
just
go
jump in
ahead.
real quick? No,
Yeah.
the thing about the slang in these terms is that people use them differently and sometimes interchange them or use them incorrectly according to like what the definition is. So I think sometimes just asking someone to clarify what it is that they're talking about or shilling. I was listening to a podcast where it was an economist debating how we even use the word money. And it's like, if we can't even all agree on how the word money is used, then, and it's been around for a really long time, then how are we going to agree on the difference between a token or a coin necessarily? So I do think that there is some alternative usage of these words, but this is kind of where we as a committee and a majority of the community, I think, sit in terms of where we position these.
Yeah, and going deeper into that slang, one term you'll probably hear pretty often is shitcoin, and that's certainly thrown around a lot. Now, we're not going to tell you what asset is a shitcoin and what asset isn't a shitcoin here, but if we take our transportation themes, you can kind of see it as a scooter. These new e-scooters that are suddenly everywhere. Some people see those e-scooters and see it as a ride to riches. This is going to get me places fast. This is going to be fun. I'm going to enjoy this. This is going to be effective. And then I can toss it inside of the road and not really care about it. Like, this is how it's seen as something useful and great to people. Or you can see it as a disaster. You can see it as it's cluttering the streets. People are breaking limbs left and right. These things are absolute garbage. They shouldn't be anywhere. They're just corporate litter, basically, in our streets. So a shitcoin is something where I, as the beholder, is this beautiful? Is this great? Is this something I love? Is this absolute garbage? It's really tough to say. But that's generally what you're going to hear, or what you should be thinking of with that term is, just because someone says something is a shitcoin doesn't mean it doesn't bring value to others. But also be careful, because you might break an arm. Now, meme coin is something you'll probably also hear, which is kind of a shitcoin without a PDF. Generally, a shitcoin pretends to be a token, pretends to have something, or doesn't pretend and actually has it, where a meme coin is it's just the shit. It's just throwing garbage around and having fun with it. So maybe a little bit more broken arms, maybe less. It's tough to say. I don't know if anyone wants to follow up with that.
I love that. One of the things that we were talking about on a different committee call was like this example: if you're riding the scooter and it seems like a good idea, then suddenly it breaks down, but maybe it doesn't break down. You have no idea. Maybe it like starts to kind of swerve around and then it's back and fine. And so with a lot of these shit coins, they might not be, but they might be. Same with the meme coins. So like, it's how you go into it, kind of the attitude you have. If you are to get a scooter and expect it to always be perfect and never to, wobble or to potentially run out of gas, whatever that is, like, probably you need to reconsider how you're evaluating that technology. Okay, so meme coin, shit coin, token, coin. We also have some standards that add in to this some other additional tokens, which would be ERC20 and ERC721 tokens. You don't need to know that, but basically tokens as an ERC20 or NFTs are another asset type that we should get into. Josh, do you want to keep going, or does someone else want to jump in and talk about NFTs and ERC20s?
I'll keep going unless someone else wants to jump in. Looks like Kent's on this.
Sure, I can talk about some of the token types here. So this is really important to understand, and it might get confusing if you're digging in and you kind of hear these terms of like ERC20, ERC721. I mean, it sort of feels like you're going down this tech rabbit hole, and what are these acronyms and what are these things? I kind of like one really simplified way to understand it is in the context of our fabulous analogy here is a 721 is really I'm sorry, an ERC20 is kind of like your standard vehicle. It's not really specialized, but it does some stuff very well. It's easy and trivial for anybody to create ERC20s on the Ethereum network. So at its inception, really, there was only ETH, the native asset of Ethereum. And as we'll see in the tokenomics section, you know, that helps. That's kind of the lifeblood of ETH. It incentivizes a certain type of behavior, a desired behavior. ERC20s are can really be used for any type of purpose. So what's a good example? Kind of the second or maybe the first wave of really ERC20s we saw back in 2016, 2017 was kind of during this ICO bubble where a project would create their own tokens and then basically put these on the market or even sell them directly in order to raise money. You could have all sorts of ERC20s representing different things, and it's extremely common today. It'd be interesting to see a pie chart of, how many ERC20s or, value-wise, what the difference is between ERC20s and 721s. 721s really got exciting, or really they didn't exist actually until I think 2018, 2019 when the 721 standard came out. This gave rise to NFTs. So you saw digital art and things like that. So, you can kind of think of these as sort of more customized things. The key thing to understand about 721s is they represent a non-fungible token. So if I were to send Josh 1 ETH out of, say, I have 5 ETH in this pile over here, I can send him an ETH, he can send me an ETH back, whatever. It's all ETH. They're fungible, similar to how you might, exchange dollars at the convenience store or something. 721s are one of a kind. So you can think of like a really cool customized limo. They do very specific things. They represent maybe one specific thing, like in the case of NFTs, digital art. They can represent customized access just for you with some unique attributes. So of course, both standards can operate on the wonderful thoroughfares of our Ethereum, highway system, but they do different things. I also want to call special attention here to this disco bus because I love this image. If you're thinking about getting more into crypto, I liken being in crypto to being on an amazing disco bus party because it's a lot of fun. So this image really speaks to me, and I think it kind of represents the fun you can have in this space.
And it also could get stuck in a snowstorm or
This is true. It's always not fun and games on the disco bus.
Yeah, you never know what's going to happen with the disco bus. And you may have a great time and then it might get stuck in, a snow pit, and then it might get out and be great again. You kind of don't know, but you're along for the ride and you have to expect the unexpected, which is why it's so interesting when people are like, I got on a party bus in this horrible storm and it got stuck and I couldn't believe it. It's like, well, you did get on a party bus in the middle of a storm. So there was an expectation this could happen, basically.
Better than being stuck on a regular bus in a storm.
Yeah. Just going back to those standards for a quick second, though, party buses are hilarious. But the main thing is, we have these standards in the space, and you might hear these terms. You don't really need to care about these terms most of the time. ERC20, ERC 721, whatever. The main thing is it lets things be consistent. You get in a car, you know where the turn signal is, unless you're in a BMW. You know where the steering wheel is. You know what's acceleration, what's braking. The car has standard features. It doesn't matter what type of car, what genre of car, it's going to work. And that's why these tokens have standards, is if I use the token in this smart contract over here, or I use it on this exchange over here, these all know how to talk to each other, regardless of the token having a different purpose elsewhere. How you interact with that token can be the exact same. So and that's why we have these standards. Otherwise, the token itself might do completely different things, but at least it has a steering wheel, and at least the gas tank has a nozzle that'll fit most things that I pull into. So this is why these standards exist, and this is why you might see these terms, and you might think, well, I thought this is a different thing. Why is it the same ERC20 numbers? This is why. It's just the interface in which you kind of interact. Now, as far as that unique part, I think now we'll probably head back over to Kent to talk about the tokenomics of it all. What are the purpose of these kind of more interesting elements of these tokens?
Yeah, thanks, Josh. So this is, I think, where it gets really interesting. And full disclosure, you don't have to really grok all this stuff. We might get slightly more detailed right now, but just the most important thing to understand at a really high level with tokenomics, and in the context of our metaphor, it's kind of like designing the economy and urban planning for a blockchain city. So what do we mean by that? It's sort of like, okay, well, what are the tolls, for example? What do you have to pay in order to use these thoroughfares? We actually touched on that in the context of gas in the prior discussion. If you're confused about that, take a look at the prior live stream, because that's a very important concept to understand. And it is in the context of tokenomics, it's important as well. But really, tokenomics is all about how to incentivize desired behavior in any sort of project or platform. So I like to start out with Bitcoin as the most fundamental OG and maybe easiest to understand example. So when you go back to the vision that Satoshi had, in 2008 when he's writing the white paper, and 2009 when it gets published, is the idea is really like, okay, this needs to be a supply or a token, an asset with a fixed supply, because in Satoshi's opinion, central banks are inflating away currencies. There needs to be a sort of hedge against that, similar to how gold has a somewhat fixed and more predictable supply, and has been a good hedge over time against central bank printing. So Satoshi designed Bitcoin with a fixed supply, set in stone, supply of 21 million Bitcoin. That is a perfect example of tokenomics. So right off the bat, he's saying, okay, he or they, she is saying there's a fixed supply, as many as will ever exist. The desired behavior, in addition to just wanting people to understand this is a scarce asset, is there needed to be some way to incentivize people to support the Bitcoin blockchain by adding new blocks to it. This, of course, requires computing power. It requires money to be spent. It's not a free thing. If it was free, really, there wouldn't be much economic security with it. So the idea Satoshi had with that is Bitcoin mining rewards. Every block, the miners that are spending resources on producing these new blocks, adding to the blockchain, are incentivized with new Bitcoin. And this has been the case since its inception, although every few years those rewards are halved. That's a really good example of tokenomics. Distribution is also important. Of course, Bitcoin is famous for kind of having this unique thing where it just started out as without any sort of, like, say, people working on it beforehand. If Satoshi released it into the wild, and people working on or mining early blocks were getting a lot of Bitcoin. But the distribution in that sense was arguably more kind of spread out, or at least given to miners. Let's jump ahead to Ethereum. Ethereum is similar in some respects, but different. It does not have a fixed supply, and really wasn't designed that way. The main reason is it wasn't designed to be a digital gold. Its idea more is this idea of like a decentralized kind of computer that anybody can use and build on, permissionless. Nobody can tell you what to do. A huge contrast to, say, like the Apple Store, where the Apple or say Google Store, where they cultivate these walled gardens that you live in, but they ultimately call the shots. And the idea with the ETH, in terms of the actual asset, is very similar in the sense that up until a few years ago, people mining on the blockchain were given ETH as a way to incentivize that behavior of building on the blockchain, just like Bitcoin. Upon the transition to proof of stake, it's now really people are incentivized to risk and stake their own capital to do that, but a very same sort of thing. And this is why ETH, the asset, exists. So separate from that, and I like to kind of call those, like Bitcoin and ETH, are like good examples of like native tokens. They're native assets. They're the reason you would want to be supporting an actual blockchain. Of course, there's way more tokens that aren't actual, that don't represent actual blockchains. It's like the projects that are built on them. So you have things like utility tokens that we discussed briefly earlier. This is like, hey, I can take this token and do something useful with it, similar to like the bus ticket idea. There's governance tokens. Shapeshift's Fox token is actually a governance token. It gives you the ability to exert some sort of influence via voting behavior over the direction of a community or a project, maybe on a pro rata basis with how many tokens you have. Of course, there's also the meme coins, and that's a little bit different because they're not designed to incentivize any particular behavior other than just maybe other people buying the asset. This is one reason why like they're more speculative. And then finally, you have like kind of those ICOs I mentioned, where people are like literally investing in a project. They're giving a project money and then hoping to maybe see their value appreciate. Those can also be ICO or also be utility tokens. That sort of ICO bubble happened previously in 2017, 2018. We may see a return to ICOs given some recent regulatory changes. But again, at the end of the day, some really important questions to ask with tokenomics is like, why would anybody want to own this token? What behavior are the designers of the token and the people who released it? What are they trying to do? And finally, one very important thing, who owns this token? One thing to keep an eye out for, and we don't want to go too far like down the investment rabbit hole here, but like a lot of times in the context of blockchain-based tokens, you see a distribution where a relatively small number of insiders hold a disproportionate amount of the token. This can be a red flag because they have the ability to really exert a lot of influence over what the token does and things like that. Generally, in decentralized paradigm, it's good to see a more spread out distribution of tokens. But these are some of the core things to understand. And again, without tokenomics, without the idea of crypto economic security, decentralized blockchains, I don't think could really exist. They would be easy to hack. There'd be no reason for people to support them other than simple altruism.
Donald, did you want to jump in?
No, go ahead.
Oh, okay. I thought you unmuted. Yeah, we're lucky to have somebody explaining tokenomics who literally was in charge of tokenomics for an organization or for a DAO for a long time. I think one of the kind of takeaways from what you said, Kent, is like, we're not giving investment advice, and really very few people can with things like this in terms of absolutely knowing for sure where the token is headed, up or down. It's all relative to so many different things. So to speculate and give a absolute certainty for what's going to happen is just something nobody can do. But you can do things like look at what the utility is. What is the purpose of this? Is it a governance token and being used for something that has value? Or what is it that the purpose of the token or coin is?
One last
Also
thing I just want to add on
sorry, go
here
ahead.
that's relevant to this, and I think it's one of my favorite examples of the unique things that blockchains can do is on a blockchain, everything is inherently transparent, with the exception of some privacy preserving technologies that are kind of still in the relatively early days. But with tokenomics, it's incredibly powerful because you don't, for example, you don't have to trust somebody that you didn't have to trust Satoshi that wait. Okay, he says that the hard limit is 21 million. Well, it's actually hard baked into the code. The community of miners would have had to like really override that and fork the network to change that. It's similar with with any given token you see out there, you can go to the say to Block Explorer, to Etherscan, and look at the contract and see what the current supply is. You don't have to take anybody's word for it. There's no trust there. When I was at the Shapeshift DAO, I could say, hey, we have 2 million in stable coins for the community in the treasury. You didn't have to take my word for it. You could simply go to Etherscan and verify that our up to the second listing of our assets. And this is such a powerful thing. So in our wonderful, fabulous, utopian city of the future built on Ethereum here, one of the core things is everything is really out in the open in a way, at least with these important aspects like tokenomics. And I just love that aspect of blockchain tech.
I think one if we go back to still like the space is always developing as well. Urban planners don't always get things right though. So although the tokenomics of a project might sound logical, might seem like, you know, the best thing since sliced bread or the car or the wheel, it doesn't always work out as planned. There are many traffic projects that have been like, okay, well, we're gonna change these roads, we're gonna add these subway stops, billions of dollars are spent, years are put into development, and then as soon as it starts, it's like, oh wow, we didn't see that coming, or humans don't interact like we expected, or computers don't interact like we expected, and now none of this works like we hoped, and it's failed. So just because something has great sounding tokenomics, especially in a space like Ethereum, because there's so many pieces that interact with other pieces, sometimes that planning doesn't necessarily go as we hoped either.
That's a perfect segue into the next topic about experimenting with new designs in the ecosystem and how it can be done without, putting the tests directly on the road where lives are at risk or things like that, metaphorically, of course. But on that topic, mainnet versus testnet is something very prevalent in the Ethereum and blockchain spaces that make the continuous development possible while maintaining the priorities of security and transparency and things like that. So with that, the mainnet can be seen like the real world highway that's fully operational. You have cars driving, people behind them whose lives are at stake. Real tolls are being paid, and you're really getting from point A to point B. And when you think of the tolls being paid, it's almost like gas fees are being paid. When it's really happening, there's real money involved, as I mentioned. So this would be the actual infrastructure where everything is permanent and operating. And just like the public highway, all the rules must be followed to ensure the safety and efficiency. So as traffic increases, as long as the same rules are in place and being followed, it doesn't matter if it's rush hour or a less busy time of the day, everybody should be safe and the roads should be working. And then the testnet, on the other hand, is almost like a closed racetrack for car manufacturers, let's say, for example, that is not meant for everyday use and actual driving, but it's used for experiments, adjustments, and done in a controlled environment. So it would mimic the highway and operates under different conditions where real money wouldn't be used. It would be testnet money in this case, and everybody involved knows that they're trialing something out. They're not expecting to get to their grandma's house from those roads. They know that they can test out the flames in the back of their car. So this allows developers to actually safely experiment with new applications, smart contracts, tokenomics, and all other aspects of blockchain technology without the financial risk or real world impact. Is there anything to add in the group?
I think I would add that, we've done live streams before, like on the merge. This is a few years ago. And what we were all excited about is that all of these changes, the change from proof of work to proof of stake, had been, they were practicing. They were doing different things on test nets before it became part of the actual main net. And just because everything works on a test net does not ensure 100% that it's going to work on the main net. And that creates kind of this buzz. Is it going to work? And then, of course, it had been tested all this, many, many times, all these different things. And then it comes out that it does work. But there's, like Josh said, in urban planning, going to be little things where, okay, everything that we planned is working, but it's not able to scale as quickly as possible. So we're not going to, get rid of the main net. We're going to add additional things to make this work more efficiently. And so it really is something brand new and innovative. So we are going to need to be able to make these changes as we go. And yes, thank you, Dustin, just reminded me there's also a devnet, which is one step up between testnet to make sure that the developers are able to be practicing this stuff. So there's a lot of different systems in place to make sure that, like, if we're upgrading code or whatnot, that it's tested in a way that makes sense. Dustin, do you want to say more about that though?
Sure, I think the main point is that there are lots of different phases at which testing needs to occur. So with testnets, it's kind of like for dApps, right? It's for people that are building on Ethereum to test their code before they bring it live. And then like with devnets, it's a different thing where it's for the core protocol itself when they're doing upgrades. For example, there's an upcoming upgrade called Pectra, and every time they have devnets where they test the new code before it's actually going to be launched. So with the devnets, they're testing all the different EIPs that they're going to integrate into Ethereum for the next upgrade. And then once they finish that devnet, they come up with conclusions. They go, okay, the change for account abstraction has been breaking this, and then we have consensus problems with that. So we need to come back to the table and figure out how we're going to change our specifications so that the devnets, the next devnet will not have this problem. So I think what we have is we have a few analogies for how code is checked and how we are able to, dApp developers get to test on testnet, core protocol developers get to test on devnet, and then when we go to mainnet, we don't have an a traffic pileup because there's all this untested code. There's lots of testing that happens so that we are able to affirm that we've made every best effort that everything's going to work well when it goes on the actual road. I
Yeah.
think we're there.
Sorry, that's why we have a committee, because that just like added on to clarify everything that was said before. Appreciate that.
I think one area where it's interesting as well is that there have been a number of developers that have kind of started using they test on testnet, but part of their protocols require interaction with real money. And then they're finding that testnet, because testnet tokens arguably don't have real value, they are unable to test how those tokens work in an economic sense. So they're actually deploying on not mainnet, but deploying on L2s or sidechains that have economic value, but the fees are cheap enough that they don't mind losing some money testing there. So I know that there are some people that do testing not on testnet but on L2s or sidechains as well.
Ooh, this is actually a perfect segue into what are L2s. So we're saying L2s, and we're talking about layer 2 solutions. So let's get into what layer 2 solutions are so that we can clarify that a little bit more. Kent, do you want to start with explaining layer 2?
Yeah, so let's dig in. This is a very important thing to understand in the context of where Ethereum is right now and where it's been headed. In a perfect world, or maybe an idealized world where a city could handle sort of unlimited growth and everything is always affordable and usable and not congested, you'd have this idea of, say, a giant Manhattan that just stretches everywhere and everything is affordable. And of course, reality is quite different, where Manhattan is the epicenter of this thriving metropolis, and it's quite expensive to live there. It can get congested. Thus, people have an incentive to live elsewhere and kind of not be in the center. Although living in the center has its benefits, it's it's right where the action is. You're close to important things happening. So, in the context of our analogy, the mainnet of Ethereum is sort of like akin to living in Manhattan. This is where all the applications are, the big. It's where the liquidity is, I should say. In terms of like where the digital sort of wealth is for things like decentralized finance. And it's where you'd want to be, all things considered equal. The downside is it's very expensive, especially in times when you have a lot of people using the blockchain. We've seen this time and again with Ethereum. I know we've covered CryptoKitties and what happened with that in the past here on this chat, but fees can be very high because it's just a simple matter of demand. You're where everything is. So there's really fundamentally a couple ways to handle this. One way to handle the problem is simply make make Ethereum less decentralized and maybe increase the requirements for like nodes and stuff and make these things process more throughput and then ease congestion. But the problem is like the whole point of this thing is decentralization. You want it to be maximally permissionless, maximally transparent and open and immutable. And really you can't have those things as you start sacrificing decentralization. So the solution that the Ethereum community landed on, and we'll see, we're going to explore this more shortly with Dustin in terms of rollups and really specifically what's happening. But the idea is that layer twos are sort of like the suburbs. This is where people can go to enjoy a lot of the benefits of living in this metropolis, but have much lower fees. So transactions are faster and cheaper. There's not that congestion. It's kind of like commuting or bypassing city traffic. You're in this different area. You're still relying on the same core infrastructure. In this case, the EVM. We talked about that earlier. The Ethereum virtual machine, the same basic kind of skeleton of code that supports everything. Just like L2s, also rely on Mainnet for security and settlement, or rollups specifically. And again, that's a very important, crucial thing we'll get into shortly. There's also this idea of side chains, and this is a very important distinction, unless anybody has anything to add on the L2 slide here. Cool. Okay. So you hear about side chains, and this is something that's been around even since Bitcoin, this idea of side chains. And you've seen this on Ethereum. Polygon is actually a really good example of like a vibrant side chain in the space. So this analogy is a little bit tricky because, so in a sense, side chains are a little bit like a sidecar where, here you have this this thing that's kind of attached to this other thing that's driving. But the reality is like sidechains are really their own entities. They're kind of they relate to the mainnet. For example, let's take Polygon as an example, a sidechain. They relate to the mainnet in the sense that they are very close, not quite identical, but very close in terms of that fundamental infrastructure. They're using the EVM. That means that anybody, say, publishing a decentralized application on Ethereum, it's super easy to port it over to say Polygon, to a side chain. You've seen a lot of these. There were a ton during the last real market cycle, and they also address the problem of congestion and high fees, but they do it in a very different way by having their own consensus mechanism. So sidechains, and this is the most important thing to understand, sidechains are their own entity in the sense that they're kind of doing their own thing. They have their own economic security. So even though Polygon, for example, is a sidechain of Ethereum, Ethereum's consensus mechanism and its economic security has nothing to do with Polygon. Polygon has actually its own set of stakers. It's a proof of stake mechanism providing that security. Of course, there's other examples as well. I keep talking about Polygon. I think they also have a ZK implementation, which is more of a rollup, but that's an important example. So the name sidechain is a bit of a misnomer because it kind of implies that the two are attached at the hip, when in fact sidechains are really their own entity. They just enjoy this sort of like common infrastructure that makes it easy to kind of exist in both worlds, or for users to move out. But compared to rollups, which we're going to hear about next, I think, they're not joined at the hip in the same sense of like having that same economic security. Thus, rollups have really been kind of the answer in terms of how do we preserve those beautiful properties of decentralization while solving some of these challenges of a growing city like congestion and high fees.
So talking about rollups now, one of the ways that Ethereum has developed a solution towards congestion is thinking of the road as your limited resource. If you had a road that's maybe, or even like a city that has a limited number of roads, and everyone's in a car, and a car can fit at most, 1 to 4 people, you can try to optimize that a bit, right? You can try to say, I'm going to organize carpooling and stuff like that. And then carpooling can maybe get your ratio up a bit, which is you have 4 people, 5 people per car. When I was a kid, my parents used to like bring me along so they could carpool into the city because Singapore would charge congestion charge if you went in with like just 2 people. So they would have me half asleep in the back seat, and then like, okay, we're getting past the toll booth now. Put your hand up so that they can see that we have 3 people, and therefore we're allowed to drive into the city. But the thing about that practice is that ultimately you're constrained by the size of the vehicle, right? Most vehicles can fit at most, 4 or 5 people, and then you've taken up that part of the road, right? Which is a car's worth. With buses, with trains, we have a much higher density, and that's kind of what rollups do. Rollups take the limited resource, which is block space, where every block has transactions in it. And what a rollup allows people to do is that you can pack lots of transactions into a bus or into a train. And once you get that, you have much better density, you have much better efficiency in terms of being able to pack a lot more transactions into a rollup. What I like to say is that it inverts the property of the individual transaction fees. Because if you drive a car in every time, you're owning the car, you have to pay the gas, you have to pay the maintenance, everything. When you take public transport, that's abstracted from you, you pay the fare. And what happens is that, you're going into the city for $1, $2 or something like that. If you own a car, that's like a whole different thing. So I think of rollups and in this analogy, using the L1 is owning your car, doing your maintenance and everything, just to be able to drive into the city. And if you have good public transport infrastructure, rollups allow you can take a bus, you can take a train. If you're really pressed, you can call a Uber or rideshare. And what that allows you to do is you have the convenience of a car, but you're not paying all of the fees associated with it in terms of the maintenance, the taxes and everything. So I think that that's a decent analogy for you have a limited resource, which is block space, and there are much more efficient ways to use that block space, especially when you use public transport.
That was awesome, Dustin. We originally were going to talk about like different types of rollups a little bit, but maybe we should skip that because we only have 10 minutes left. If you guys are okay, what do you guys think? Should we skip the types of rollups and get into bridging?
Sure.
That makes sense? And because we've done
Navigating Ethereum Part 13 coming next week.
Okay, let's jump into bridging then. And we've got some stuff on rollups already on videos. Just so if you're watching this and you want to learn more about Ethereum rollups, we've got other videos on that with more specifics on optimism and zero knowledge rollups. But let's get into bridging, which
All right.
Josh is the person, and Josh, good luck, because this is the most imperfect analogy out of all of them, but I think it's going to be helpful to explain it anyways. Go ahead, Josh.
So there's generally a saying amongst nerds and geeks and technological folk is that we are one of the hardest things in computer science is naming things. And we see it a lot, especially in the cryptocurrency industry, because a lot of it is just hardcore technological geeks who have given something a name because it made sense at the time. But if you look too closely at that name, it really breaks down really fast. I think wallets is certainly one of those things where it's like, oh, it's a wallet, it holds my crypto. Oh, but it doesn't hold your crypto, it actually holds a number. Oh, it also lets you look at the network and see your balance on things. It just falls apart. It made sense, but here we are. When it comes to bridging, this seems extra hilarious for this particular talk because bridging is extremely related to transportation. This is perfect. This is going to be the easiest one. It's a bridge. You drive across it from one area to the next. I'm on one chain. I'm on my Ethereum mainnet chain. I'm in Manhattan, and I'm driving across the river to a different chain to go and interact there. Beautiful. The problem is that's not actually how bridges work. You're not actually transferring the car from one section to the other. So this analogy fails miserably, despite the fact that bridging should have made so much sense for transportation. What actually happens with bridges is you get to the end of the bridge, or you get to the start of the bridge, you lock up your car in a parking lot, I guess, and then you walk across the bridge where the same car that you locked up, same model of car that you locked up, is made available for you on the other side of the bridge. So it's not like you're not driving across the bridge. That would have made so much sense. You're bridging yourself across. No. You are locking up your car, and then somehow on the other side in this new city, your kind of same car is there, but it's not actually your same car because your same car is locked up. But ultimately, you would know how to drive it. It's the same thing. You can interact with that car. So we found it hilarious that, bridging doesn't really work for our navigating Ethereum analogies, but luckily it's so broken that we hope you now understand why bridging, or how bridging works, based on the fact that it doesn't actually work this way.
I love it, Josh. It very much so is unfortunate that the the word that seems like it would fit most doesn't actually work. Yeah, it's interesting to think about it like that. It's locked, it can't move, but yet somehow it is in this other place, but yet not.
And then if you want your car back, you just drive it back to, you drive this new car that you somehow got, that's the same car, back to the bridge. And then on the other side of the bridge, you get yours back. But also, because it's weirder, and kind of, Kent mentioned earlier, well, 1 ether is 1 ether is 1 ether. When I get back to this side of the bridge and I get my car back, there's other things in the glove box because it's not actually my car. It was someone else's car, but it's the same make and model. So the system seemed like that was the one that was going to unlock for me, and it's fine, and I should be happy about it.
So I know that the image is still on the screen. So for you watching, we've all been sort of smiling and nodding along in terms of like, yep, that's how it works. What else should we add to this to make it clear? Anything?
I think for me, the analogy that fits for bridging the best is actually kind of like when you go to an arcade. Arcade, you used to put in like, coins, right? But for the longest time, arcade operators like, no, we're not going to do that. We're going to give you tokens. So you come to the arcade, you give us money, we'll give you an equivalent number of tokens that you can use in our arcade machines. And normally those tokens only work in that arcade. So that kind of fits the bridging analogy well. Another thing is casinos, where they don't let you use real money. You go to a casino, you change your money, you get casino chips. You can play with these casino chips in any part of the casino that you want, but when you're done at the casino, you go back and you cash out your chips. An interesting thing about this is I've heard that there is an offshore way of doing leverage where you go into a casino with these chips and you play with them, but then there are people that leverage the casino chips outside of the casino, and if you go out with those casino chips, they will give you more money than the casino actually changes for you. And I'm not exactly sure how that works, but that is kind of, I feel, the best analogy for bridging, which is you go in, you put money that's locked up, and then you can unlock that. You get the tokens, which you can only use in a controlled area, which is where you bridge to. And then when you want to get your stuff out, you go back to the person and you change it again, and then you can unlock those funds.
And again, you're not getting, if you put in $100 and then you bring those chips back and things have gone well, you still have your $100. They're not going to go through their inventory and find your $100 bill to give you. They just have, 100 of that asset to give back.
Just one more thing to add in terms of the analogy here. Kind of touching on Josh's idea of like, this idea. It's almost like it reminds me of a ferry. I was in Thailand after DevCon last year and was in an area where you had to, take the car and you put it on a ferry and then you go across. In the worst case scenario, bridging your assets can be like getting on a ferry and the ferry sinks and you die. All your assets are gone, or the bridge collapses. So one important thing to understand is that bridges inherently involve some sort of sacrifice in terms of like the decentralization and trustlessness of Ethereum. If you're working strictly with mainnet, everything that happens is on mainnet. You don't have to worry. You still have to worry about, like, say, well, could this application potentially take my money? There's threats out there you need to look at. We could dig into that at some other point. But really, in terms of the network, everything, it's, you're in the same area. There's been many cases where millions upon millions of dollars were lost when bridges designed to take users from their assets from one network to another failed or were hacked. This has happened many times. So whenever you're considering bridging over to a different network, be very mindful of who's facilitating that. Is it a trusted centralized exchange, somebody that should really optimally be in a good position to do that? Is it a sort of group of people that are claiming to be able to facilitate that? But be very, very, very aware that not all bridges are considered equal, and really inherently there's always some risk in terms of bridging your asset to and from different networks of varying degrees of risk.
Yeah, I think that like a lot of what we've said is that you need to pay attention to what you're using, do some research to see if it aligns with like your beliefs. And also just be like curious and question what you're doing rather than just making the assumption that like, yeah, the ferry or the bridge looks shiny. That doesn't actually mean that it's structurally sound. So you need to pay attention to what you're doing, where you're going, how you've got your assets locked, and all of that. And also have fun with it, as long as you're not, investing so much that you can't function. If you lose it all, then you can, enjoy the party bus of meme coins, and you can use a bridge and play around, things like that. You just have to be aware. Like if you're using a bridge, are you going to like put the best car in the world on it, like a $200,000 Maserati? I don't know if that's how much those cost. Or are you going to put like a beater to practice for the first time and see how it goes, things like that. Okay,
It's worth mentioning that that bridges, especially bridges that are newly launched, will often give you incentives to use them. They will like, I may airdrop some tokens, and they're using points these days. So they're like, get points if you use my bridge. So it's not often that straightforward, as in they will often be incentivized to get you to use the bridge. So don't be suckered in by incentives to use the bridge and not look carefully at what the bridge is actually doing and whether it's custodial or non-custodial. You should understand things like that before you put things onto a bridge.
Yeah, good points. Well, this was part 2 of Navigating Ethereum. Sorry for rushing through the roll-ups part of it, but I think we got the main part of it, and we could probably go on for like 20 sessions on this. So I think this is, if we kept going, we'd probably get too deep in the weeds for an introduction to Navigating Ethereum. I know, Josh, we always do. It's so hard not to. Once you've learned it, it's hard to kind of pull back from all of it because it's so exciting to see what is actually happening. But if you're new, thank you for joining. If you're not new, thank you for joining. We appreciate you listening and learning from C4. And thank you to our incredible committee members. Without you guys, we would not be able to have unbiased content that we crowdsourced from people within the industry. So thank you guys for joining. I appreciate, and we will see you guys on the next live stream. So thank you, and we'll talk to you guys soon.
Thank
Bye.
you.
This is me, my carpool car.
Okay.